Hi, welcome to part 2 of my 3-part series on water vapor equilibrium. In this part, we're going to be extracting some data, some temperature and pressure values from the Dortmund Data Bank concerning water vapor equilibrium onto a Google Collaboratory. So I'm going to show you how to do that. Alright, first things first, let's discuss some of the imports that I've already typed in here. I'm going to be using these imports and the same code for part 2, this part, and part 3, where I'll be making some diagrams of the data with Antoine's equation. So, not all of these are necessarily necessary for this part, but I've already included them. So this first thing is necessary. LXML is a library with import HTML that supports XPath, which allows us to read an HTML and scrape it for the data that we want. And then this request thing is an HTTP library written in Python. We've got JAX. JAX augments NumPy. It does automatic derivatives, which we'll use in part 3. But NumPy is just something that assists in doing arrays of numbers in Python. And then this optimize minimize function we will use also in part 3 to minimize the sum square error. I'll talk about it in part 3, but basically it's just used to minimize a function with one or multiple variables. And then we've got plotly, which again we'll use in part 3 to make some plots, diagrams. Okay, so let's see. Alright, so first thing I'm going to do is get the data. This is the, this is the Dortmund Data Bank website. It's just got endless pages of data, specifically chemical stuff, and this is the page that we want because it's vapor pressure of water data, experimental data. It's got the temperature values in Kelvin and pressure values in kilopascals, and this is what we want to extract. This is what we want for our code. So I'm going to show you how to do that. The first thing that I need to do is copy the HTML, or the URL, I guess, which what I did, and I'll show you how to do this, but what I did was I put it in a GitHub repository, and that's what I'm going to use. But the way that you would do that is you would just right-click on the website itself, do inspect, and then HTML, right-click, copy element, and then you would put that in whatever you want. I use GitHub. And then here it is, raw. And you can see right here, if you can see my mouse pointer, these are the data numbers that we need. So I'm going to copy and paste this URL, Control C, and then I'm going to do URL equals Control V. Alright, shut down. Okay, so now that we've got that, we are going to actually get data from the website that we want. But first I need to do, I'm going to type this out and then I'm going to explain what it is. And we're using the request function that I talked about, or import, I guess. Well, we've already got that defined. Content. Okay, so what this does is it stores the content, the actual data on the website, like all the stuff, instead of just the URL as the content. So now we've got the actual stuff. Okay, and then now we want to make that into a like tree format or structure. Oh, that's string content. Okay. Okay, so now, again, this line stores, or it, takes the actual content from the URL. That's what this request.get is. And then this line, now we've got it stored under like a tree structure. That's called tree. Shift enter. Okay. So now I'm going to go back to the Dortmund Data Bank website and actually get the data values that we want, the pressure and temperature values. So here we are. What I'm going to do is I'm just going to, let's do temperature first. I'm going to right click on one of these values, inspect, and it should highlight it there, yep, and it highlights it here. So I'm going to right click on that too, and I can copy the XPath of this value. And I'll explain that a little bit further in just a second. So I'm going to, because the XPath, initially when we get it from this website, the values that we take from it are going to be stored as strings, and we want them in, obviously, numbers, decimals specifically. So I'm going to call this temp strings, and eventually we'll convert those to numbers. Sorry. Okay, equals, and we're going to do that tree dot XPath. Oops. Okay. And so since we inspected and copied the XPath, we don't have to type it in and figure it out. That's what's great about XPath, but I'm pretty sure this is quotes. Control V, and then we need to do /text. Okay. Alright, so now we need to do the same thing for pressure. Pressure underscore strings equals tree XPath. And again, I'm going to explain this in just a second. So what I could do is I could literally copy this entire line and paste, and obviously change the variable name. But then I could literally just go in and change this number from a 1 to a 2, and that would give me those pressure, the XPath of those pressure values, because that's what it is. But I'm going to actually go and get the XPath for the pressure values like I did for the temperature. But I also want to point out a mistake that I have made multiple times previously and just figured out is I need to get rid of this, because this gives the XPath of a specific row, but if I just delete this 3, then that gives me that entire column with no row specification. So now this is the XPath of that entire column of temperature values. So I'm going to do the same thing for pressure. Go back to this, get rid of that. I'm going to right click on a pressure value, inspect, right click on the highlighted, copy XPath. Alright, and then Control V, /text, that's just syntax. And then, again, I need to get rid of that row specification. And as you can see, like I was saying earlier, 1, 2. Alright. Okay. So now we've got the temperature values stored under temp strings and the pressure values stored under pressure strings. I'm actually going to shorten that to press strings just because I'm picky. Okay. So now for the final thing for this video, I'm going to convert these into an array of decimal numbers. And then in part 3 again, I'll make those diagrams. So what we're going to do for that is, I believe that's how we're going to use munging, and I'm going to call this data. Munging.array. Temp strings. This strings. So that's our array, but then we're going to do dot as type. numpy dot float. And these are the different options. This float 64 is double precision, which is going to come in handy later, so I'm going to use that. But yeah, then so data equals an array of our temperature strings and our pressure strings, and then as type float, which floats are decimals rather than strings, which are just words. Okay. Shift enter. And that should work. Let's test that really quick. Let's do data, shift enter. And there you have it. There's our data from the Dortmund Data Bank that we wanted in an array. So we'll use that in part 3 to make a graph, scatter plot specifically, of Antoine's equation of this data. So thank you for watching and stay tuned for part 3.